Okay, so now we'll be studying the second method of Rangi Kutta, which is the fourth order method. Okay, so now to basically in Rangi Kutta fourth order method, um, it is used for finding the increment k of y corresponding to an increment h of x. ठीक है. So now this is the form of the ordinary differential equation, right? So steps, these are the steps. Okay, you have to calculate successively. I mean to say, by successively I mean that these steps will be followed one by one. Okay, you cannot jumble these steps. First you have to find k1, then you have to find k2, followed by the findings of k3 and k4. Fine. So now to find k1, this is the equation, that k1 is equals to h of f x naught at comma y naught. Fine. Then this is k2. The value of k1 is involved here. This is the reason that you have to find k1 first. Similarly, when we are finding k3, the value of k2 is required here. So we have to find k2 before finding the value of k3. And finally, when you are finding the value of k4, then you have to find the value of k3 before that, right? So all these values are basically being used. Finally, at last, we compute the value of k. What is k? K is the weighted mean of k1, k2, k3 and k4. Now I don't know if you are able to recognize this thing. This format is same as Simpson's rule, right? So basically this is being derived from there only. Like during the derivation, they have used the Simpson's rule to find the weighted mean of k. So anyways, so after finding the value of k, this gives us the required approximate value of y1, which is y naught plus k. Okay, so now we'll solve an equation, solve a question. Okay, apply Rangi-Kutta fourth order method to find an approximate value of y when x is equals to 0.2, given that dy by dx is x plus y and y is equals to 1 when x is 0. Okay, so now what are already given in the question is that x naught is 0, y naught, I mean at x not equals to 0, y naught is 1. Okay, these are given in the question, and we have to find what? We have to find the approximate value of y at x equals to 0.2. This is the reason we are going to take h equals to 0.2. Fine. Now f of x naught y naught, this means that f of xy is this. Okay, now put the value of x naught y naught here. X naught y naught are 0 and 1, so 0 plus 1 is 1, right? So this is the reason this is 1. Now we are going to calculate successively the values of k1, k2, k3, k4 and finally k. So now the first the value that we have to find out is k1. So k1 is equals to what? H of f, h into function at x naught y naught. This was 1, so 1 into 0.2, so this is 0.2. 0, 0 I added afterwards. It doesn't matter, you can keep it 0.2 only. Now next is we have to find the value of k2. k2 is h into f of x naught plus 1 by 2h and y naught plus 1 by 2 k1. Now h is 0.2 and this is what? X naught is 0, h is 0.2, 0.2 by 2 is 0.1, so 0.1. y naught plus 1 by 2 k1, y naught is 1 and k1 is 0.2, 0.2 by 2 is 0.1, 0.1 plus 1 is 1.1. Now 1.1 plus 0.1 is what? 1.2. 1.2 into 0.2 is 0.25 0.2400. 0.2400. Okay, so this is the value of K2. Now what about K3? Again this is 0.2 into x naught plus 1 by 2 h is what? 0.1 only. It's the same as before. Y naught plus 1 by 2 K2, not K1. This has changed. Usually people make a lot of mistakes in these questions. You have to remember this thing, okay? Anyways, K2 is what? 0.2400. 0.2400, right? Divided by 2 is 0.12. 0.12 plus y naught is 1.12. 1.12 plus 0.1 is 1.2. 2 into 2 is, okay. Finally, the value of K4 is 0.2 into x naught plus h is what? X naught was 0, so 0.2, and y naught plus K3, y naught is 1 and K3 is this, so this is 1.244. Finally, by multiplying, now last we have to find the value of K, which is the weighted mean of all the 4 values of K1, K2, K3, K4. Anyways, so we are going to substitute the values here, multiply by 2 when needed, and finally the answer is going to be 0.2428. So this is the required approximate value of y, which is 0.2428. Okay. So this is how you solve questions, okay, using Runge Kutta 4th order method. Now this is your task, that using Runge Kutta method of 4th order, you have to solve dy by dx equals to y square minus x square upon y square plus x square. What are the given conditions is the value of y at x equals to 0 is 1, and you have to find the value of y at x equals to 0.2. So I hope you will be able to do this question. Thank you.